In this video, we'll try to define voltage, current, resistance, conductance, and really just try to understand exactly what those things are. If you're studying electronics, of course that word comes from the word electron. Let's draw a very simple idea of what an atom is. You might have your nucleus here that has an equal number of protons and neutrons, and then around that nucleus you've got these little electrons, and they're flying around in orbital shells. And really, electronics is all about pushing electrons around. The movement of electrons is known as electrical current, and we'll talk later in another video about that actual flow of electrons versus the flow of positive charge, which is in the opposite direction. Both happen simultaneously, so that'll be for another video. But we have these electrons, and the first thing to really get going on being able to push them around, or maybe one of the ways I should say to play with that, is to create an imbalance. So let's just do something like, I don't know, let's just represent a pile maybe here, and maybe those little dots are electrons that are free, and maybe there's more over here than over here. Now, the chemical reaction inside of a battery is an example of how to get this done. The chemical reaction would actually strip away electrons from this area and push them over to here, and we create an imbalance. You might know already that electrons have a negative charge, so this would be the negative side of the battery, this would be the positive side of the battery. And again, in another video, we'll sort of address the flow from negative to positive as electron flow, and the positive to negative as conventional flow. But we'll save that for another one. Let's just get this idea down of what these individual voltage, current, resistance, these things are. When you have an imbalance anywhere in nature, it does want to equalize. That's the second law of thermodynamics. And here we have an imbalance. And if it's an imbalance in charge, that's coming from this idea that we stripped electrons away, so there's missing electrons here, there's an excess of electrons here, there's a name for that, and it's voltage. So when you have this imbalance that exists, you have voltage. So now we know what voltage is. That's abbreviated with a V. And again, we can also later on show you some alternative abbreviations. EMF, some of you might, if you've studied electronics or electricity before, electromotive force, abbreviated with a capital E. That's another way you can refer to voltage. So if you have an imbalance in electron charge, we'll call it voltage. Like we said, any imbalance wants to equalize. So maybe let's look at another example to sort of make this concept come to life with maybe something you've already kind of know intuitively. Let's say we had two water tanks, and maybe one has more water than the other, right? So that's very similar. Right now, I think you can see that there's an imbalance in either of these examples. There's no way for that imbalance to equalize, so here we would call this a static charge. This would be a static voltage that's developed. And here you have two separate tanks with different amounts of water. They will try to equalize if you provide a path. So in fact, they will equalize if you provide a path. So for electricity, of course, we need some type of conductor to be the path. So metals are good conductors. We'll talk about that later on too in more detail. But let's just say we used a metal wire here Okay. We now provided a path between the imbalance. And the same way that would maybe use a pipe or something to provide a path. And I think you can see what happens, just from, if you would provide a path here, and connect a way for this imbalance to equalize, it will. Immediately, as soon as you provide a path, something happens. So if you have an imbalance and provide a path, you will get flow. In the case of the water tank analogy, that flow is called current, right? So that's what you get. First you have to have an imbalance that wants to equalize, and that's a sort of a pressure. You maybe could think of it as a pressure to equalize. And then if you provide a path, you'll get current. In electrical terms, it's the same word. So current will flow right here. And the path itself, well, in electrical terminology, we have maybe two ways of talking about this path. How easy is that path for electrons to flow, or positive charge, whichever direction you're talking? We'll talk about that more. The term we use to describe how easy the path is conductance. How conductive is it? We could also talk about how difficult the path is, and that term we use is resistance. So how conductive, how resistive, or the conductance of the path, the resistance of the path are two terms. They are inverses of each other. It's exactly like calling a glass of water half full or half empty. You have described the same glass of water. Either description contains all the information you need. So if someone tells you it's half full, you also know it's half empty. And if they tell you it's half empty, you know it's half full. Conductance and resistance are exactly that. So if I told you the resistance and you wanted to know what the conductance was, you just invert it. So, and we'll do a little mini video on that too. But in other words, if resistance was 10, the units are ohms, we'll talk about that later too. But if there was a resistance of 10, it would be a conductance of 1/10. Or if it's a conductance of 10, then that's pretty good as far as it conducts well. So it has a 10. The resistance would be 1/10. It's so not much resistance if it has conductance. If it has resistance, it's not as much conductance. Okay, I think I maybe beat that to death. All right. So now you're starting to see some of the terminology that goes right along with a study of electricity, electronics. Voltage is the imbalance of charge that wants to equalize. If you provide a path to that for that imbalance, in this case, some kind of metal, some kind of conductor, that path will have properties of conductance and resistance. And given an imbalance and a path, you will get current. Now the current that flows, there's units that are associated with that. In our water analogy, I think you can probably maybe have heard of gallons per minute, for example. So you might have a certain flow here. Gallons per minute is really how many gallons of water flow past the point here every minute. And then for electricity, we're really trying to understand or measure how many electrons, if you're talking the flow from negative to positive, or how many positive charges which are flowing back this way. In either case, you're talking about the amount of charge that's flowing. So the units for that are amperes. Let's see, let's put that up here. So current is measured in amperes or amps. And what is an ampere? Well, it's a certain amount of charge flowing per second. An ampere is 1 coulomb per second. And I guess that begs the question, what's a coulomb? So a coulomb is just what we had down here, sort of like the gallon of electrons. In other words, if you're trying to measure the flow of water, it's awkward and impractical to try to talk about how many water molecules are flowing past a given point every minute. So we don't say, I mean, that'd be a big number, you know. How many H2O molecules are flowing every minute? Not practical. So we have a unit called the gallon, which is a whole lot of water molecules, right? Same thing with the coulomb. So 1 coulomb is about, well, it is defined, it's, let's see if I can measure, I think it's like 6.25 times 10 to the 18th electrons, or or missing electrons. We'll get to that in another video. So it's a lot, and again, it's the same thing. There's so many other analogies. Like if you were, I don't know, if you were talking about how much sugar to put into a cake that you were baking, you're not going to see the units as how many grains of sugar. You're going to see it as 1 cup of sugar. So think of the coulomb. If it helps you remember, maybe C for coulomb. You know, in baking, it's a cup of sugar, rather than referring to how many granules. And in electricity, it's 1 cup of electrons. There's this many electrons in 1 coulomb. And for 1 ampere, you're seeing that there's a flow of 1 coulomb of charge every second. So it's this many electrons moving every second. That would equal 1 ampere. 1 ampere or 1 amp is equal to 1 coulomb per second. Okay, let's see how we're doing with our terms. Imbalance is voltage. We've got a path that has conductance or resistance. Let's see, current is the flow. In upcoming videos, we'll add the units. You know, what are these all abbreviated as? I think I'll keep this video short as just sort of defining, you know, physically what these things are, and then I'll do some more videos that actually get into the abbreviations for all of these. How do you abbreviate voltage and volts and current and amps and so on? There's letter abbreviations for all of these items. So we'll try to keep it short. We'll also get into, of course, a video that quickly shows you the relationships of these things: voltage, resistance, conductance, current. And that's known as Ohm's law. And you can see, just as a little bit of as we finish up this video, let's just sort of show you while we have these analogies. I think you already know Ohm's law. I mean, look, what happens if this water level would be doubled? You know, right here. The imbalance is doubled. The voltage is doubled. Okay, so the pressure is doubled, and so I think you can see the current would of course be doubled as you double the pressure, right? So Ohm's law addresses these basic relationships between voltage, current, and resistance. So you can take a look at those. Of course, the mower goes by just as I'm wrapping this up, but just bear with me. And then we've got the maybe a couple other things. I don't know. Let's say I doubled the voltage, you know, doubled the imbalance. If I wanted to keep current the same, I mean, here this is going to double current. What could I do? Can you think? I double the pressure, twice as much pressure to equalize because the imbalance is twice as great. I don't want current to change. All right, why don't we just make the path, like, you know, half as conductive or twice as resistive? Do you see that, right? I mean, I could increase the resistance of the path. Now the path is twice as difficult. The pressure is twice as great, but the path is twice as difficult, or you know, I've doubled the resistance, or I've halved the conductance. It's half as conductive, twice as resistive. Current will stay the same, right? That has an offsetting effect. So those are the things that we'll address in a video about Ohm's law. It's simple, but it's very important. It's in the end, I mean, it's all that. I say electronics is just pushing electrons around, and then the other thing you would add to that is with the knowledge of Ohm's law, which isn't crazy difficult. It's very simple, but you'll be surprised how many problems you can solve as long as you believe Ohm's law. You know, that's what you'll hear me say that a lot. So, but yeah, so these relationships we'll explore, and I think you can already see exactly what that'll entail. You know, all those things. I could put the voltage if this water level was cut in half. Voltage would go in half, and so on. So yeah, maybe we'll do that in another video, so this one doesn't get too long, and we'll stop it here. I'll think if there's some other terms that I missed. Upcoming videos, then we'll take this farther.